Unit 9, Lesson 1. This should be old review. We're just reviewing how to graph linear equations. Okay, we're not using a graph calculator initially. We can use it to check, to verify, but you need to be able to do this without a calculator. So, standard form looks like ax plus by equals c. Now, to do this, to graph it, we're going to find the x-intercept and the y-intercept by plugging in 0 for x or for y. We're actually going to do it for both, but you only plug it in one at a time. So, if I plug in a 0 for x, that's going to give me 3, 0, which basically goes away, plus 2y equals 4. We solve for y, divide by 2, we get y as 2. So that means we're going to put a 0, 2 right there. Because we said x was 0 and y was 2. And that's 0, 2. Now we're going to do it again. 3x plus 2 times 0, which goes away, equals 4. We divide by 3, and we get x equals 4/3, which is about exactly 1 1/3. So that's 1 1/3, comma 0. So here's 1 1 1/3 is approximately right there, and then we're going to draw our line. Always using a straight edge. To get it to go through as accurately as possible. So that would be the line for 3x plus 2y equals 4. Now we're going to be putting more than 1 on here, so you might want to use colored pencils or a pencil and a pen or something like that. Even though normally I don't say pen, colored pencil would be better. So there's the line, 3x plus 2y equals 4. Now, we're going to do the line y equals x plus 4. Now this is what slope-intercept form looks like. It's y equals mx plus b. Again, this should all be reviewed for you. Find the slope m and the y-intercept b. And we always start on the y-axis. So, m is 1. That's the slope of 1. And b is 4. So let's change color here. So we always start here. And then my slope is up 1, right 1. Or down 1, left 1. And there's my line for y equals 1x plus 4. Now, we also have special lines, vertical and horizontal. X equals 5. That means x is always 5. So, x is 5 when y is 0. X is 5 when y is 4. X is 5 when y is negative 3, apparently. So I go and put these points on there. 5, 0, 5, 4, 5, negative 3. It gives us a vertical line. And x equals is always going to be a vertical line because x is always 5. The x doesn't change. The up and down, the y changes, but the left-right never changes. Consequently, on y equals negative 4, you can guess what it's going to be. Y is always negative 4. So if x is 0, y is negative 4. If x is negative 8, y is negative 4. And if x is 9, y again is negative 4. So, 0, negative 4. Oh, we're going to change colors. 0, negative 4, negative 8, negative 4, and 9, negative 4. gives me a horizontal line going through -4. And that's not going to change, because the y, the up-down, is always the same coordinate. Okay, again, this should be a review. We are solving a system of equations by graphing. Now, this is not the most accurate way of doing it. You can tell by up here, when I had to estimate 1 1/3, not always going to be the most accurate, but you do have to know how to do the skill. So, example 1, check to see if the following ordered pairs are solutions to the system. So, all you're doing here is you're going to plug in numbers right now. So I'm going to plug in 1. 1 minus 3 times 4 equals -5. And I'm going to just determine, is that point even on that line? So 1 minus 12 equals -5. Well, that's -11 equals -5, and that's false. So I'm actually already done, because if 1, 4 is not on the first line, it can't be on the intersection of the two lines. And that's what a system of equations is. It's the point where they both cross. But let's go ahead and do the work anyway. So I have -2, I plug in my 1, plus 3, plug in my 4, equals 10. So that's -2 plus 12 equals 10. 12 minus 2 is 10, equals 10. So 1, 4 is on that line, but not on the first. So that is not a solution. That is to the system. Now let's try it again. X is -5 minus 3 times 0 equals -5. Well, 0 times anything is 0. -5 equals -5 is true. So -5, 0 is on that line. Now let's see if it's on the second one. -2 times -5 plus 3 times 0 equals 10. Again, 0 times anything is 0. Negative times negative is positive. 10 equals 10. Check. So this is on that line, which means it is a solution. And here we always should say no. Okay? So yes, it is a solution because it is on both lines, which means it is on the intersection of the two lines. All right. Now, to solve a system of equations by graphing, you graph both lines and look to see if they intersect. So the last one we just did, -5, 0, it did cross at that point, -5, 0. Now, when we graph them, if they intersect, they will intersect at one spot, like this. Or, if they are the same line, like so, then they have infinite solutions because one is lying on top of the other one. Kind of like when they repave a road. It's the same road, it's just on top of the other one. Or the other idea is you could have parallel lines like that where there's no solution because they're never going to intersect. So down here, we're going to use the system, whatever system we want, to graph all these lines. Okay? So you can do intercept, y equals form, whatever you want to do. Let's just see what makes the most sense. So 2x minus 2y equals -8. I'm going to plug in 0 for x. Whoops. I'm going to plug in 0 for x and see what I get for y. And I'm going to plug in a 0 for y and see what I get for x. Now I'm just going to kind of do the cover-up method, which you can do mentally. So if I plug in a 0 for x, that means I'm going to have -2y equals -8. If I divide by -2, that's going to give me +4. do the cover method again. I plug in a 0 here for y. That's going to give me negative 4. I'm going to do the same thing here now. I'm going to plug in a 0 for x and a 0 for y. And since these are easily divisible, I can just do it in my head. So I'm going to plug in a 0 for x, and that gives me y equals 2. If I plug in a 0 for y, then that's going to give me x equals positive 2. So, 0, 4 is right here. Negative 4, 0 is right here. So I'm going to graph this line, and again, you're going to use a straight edge. Like so. You can tell I'm using a straight edge. And then 0, 2. And it is a nice idea to use different colors. 0, 2. And 2, 0, which is going to be over here. And then you estimate where they intersect, and then you say, well, that looks to me like it's the point negative 1, 3. Now, what you should do now is to verify. You should plug these numbers in to both equations. So when I plug it into the first equation, negative 1 times 2 times 3 equals negative 8. So that's negative 2 minus 6. That's negative 8 equals negative 8. Check. And then I plug in the next one. 2 times negative 1 plus 2 times 3 equals negative 8. Well, that's going to be negative 2 of course, it'll help if I pay attention, and that's going to be not negative 8, but it's equal to 4. So that gives me 6 minus 2, 4 equals 4. Check. Good to go. I confirmed that that point is on both lines. Now, even though it looks like it, you do have to check. Okay, y equals negative 2. Y is always negative 2. So that's one of these special lines where y is always negative 2. It's a horizontal line. I'm good to go. X plus 2y equals negative 10. I'm going to plug in 0 for x. Plug in 0 for y. So cover-up method, 0 for x. Negative 10 divided by 2 is negative 5. Cover-up method. X equals negative 10. So, 0, negative 5. Right here. Negative 10, 0. Right there. Now, this is where you definitely want to use a straight edge to find the intersection point. Now, since I can't use a straight edge on the smartboard, I have to cheat or use math and look and see what the slope is. So I'm going up 5 and left 10. Up 5, left 10, which is a negative 1/2 slope. Which means I'm going up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. That gives me a way to connect my dots without having a ruler. So it looks like the point of intersection is negative 6, negative 2. So what do? I plug that in. Well, the first one's easy. Y equals negative 2. Check. Now I need to plug in the second one. So negative 6 plus 2 times negative 2 equals negative 10. Well, negative 6 minus 4 is negative 10 equals negative 10. Check. So this point is a solution to the equation. Okay, last two. I'm going to use cover method here. So, plugging a 0 in there, that gives me 12 divided by 4 is 3. Cover method. 12 divided by 2, x is 6. So that gives me 0, 3, which means right here, and 6, 0, which is right here. Again, I'm going to get my slope, which is down 3, right 6, down 3, right 6, which again is a negative 1/2 slope. So that gives me an idea of where my points are, so I can graph this a little bit more accurately. I want to make this line as good as possible, because you want to be completely accurate when you're doing this system by graphing. Okay, this one I'm going to use the y-intercept, y equals mx plus b method, slope-intercept form. So my intercept is 3, that's easy. I can tell right now where it is. And then negative 1/2, well, we just said that was the same slope, so look what we got here. This is the same line, so my solution is infinite. It's the exact same line. All right, last one. X minus y equals 5. Cover method. Plug in a 0 for x. Now you got to be careful here. Negative y is 5. So y is negative 5. Plug in a 0 for y, and x is 5. So 0, negative 5, right here, 5, 0, right here. That is a slope of 1. So there's that line. And then this one, I need to get y by itself. I could use the cover-up method. I'm just going to divide by negative 2 here. And that's going to give me positive y equals, I'm going to put the x term first. So negative 2 divided by itself is just positive x. And then negative 9 divided by negative 2 is positive 4.5, or 4.5. So, again, this is one of those ones where it's kind of inaccurate because you have to start not at 4, not at 5, you're starting in between at 4.5. But the nice thing about this one is we know the slope is 1. So that means I'm going to go up 1, right 1, and it's going to be in between. And down 1, left 1, that's going to be in between. And since I said earlier that this had a slope of 1, and this has a slope of 1, that means the lines are parallel and there is no solution. They will never cross. That's it.